Hey everybody, welcome back to Java A to Z Fundamental Speed Training in 90-ish minutes with Coding Nomads. I'm Ryan Desmond, and this is part 2. If you haven't already watched part 1, where we go through Java data types, variables, operators, conditional statements, for loops, while loops, if statements, and basic data structures like arrays and array lists, please refer to part 1 of this training. In this session, we are going to be focusing on Java classes, Java objects, Java methods, object-oriented programming, understanding static versus non-static, and understanding packages. And again, just to kind of refer back to Coding Nomads online learning platform here, this webinar, although very fast and not covering all the information, is doing its best to follow very much along what our online fundamentals of Java online course looks like. So you might recognize that in the previous video, we talked about primitive data types, variables, operators, flow control, and conditional statements, data structures, arrays and array lists. In this video, we're going to be talking about classes, objects, methods, object-oriented programming, static, non-static, and packages. And this online course, the third video, we'll talk about exception handling, input-output, multi-threading, generics, enumerations, and lambda expressions. And this, from my many years in the field as a Java developer, when we're talking about Java fundamentals, these are the really important things to know right now. I should also mention that I am discussing Java 8 here, because, or Java 1.8, because Java 8 is by far the most widely used version of Java that's being used out there in the commercial world, like by actual developers and actual companies. Java 9, 10, and 11 are all still kind of in development. They're great, they're good to learn, but the general industry will take some time before it fully migrates onto those newer versions. So let's hop right back into the code. Again, in the last video, we talked about data types, variables, casting, operators, all the loops and if statements. I guess we should probably come back to a switch statement at some point, and as well as arrays and array lists. In this section, we're going to be talking about classes, objects, and methods, object-oriented programming, static, non-static, and packages. So let's just go ahead and jump right in. In the previous video, we were basically just, we weren't really thinking about classes. We just had a class of any name that had a main method, and the main method was just executing some code so that we could understand variables, data types, operators, loops, arrays, etc. But Java is an object-oriented language, meaning it allows us to build objects that represent anything, whether it be the physical world around us, some idea on your computer, some picture from the surface of Mars, whatever it might be. We can basically build a Java object that represents that, and then we can use that. And classes are known as what are basically known as blueprints for objects. So they're not the objects themselves. They're a blueprint for the object, just like you can have a blueprint for a house, and you could you could build that house 10 times with those same blueprints. The same thing is true of a Java class in relation to a Java object. The class is like the blueprint, the object is like the actual physical house. And so classes have attributes, and very oftentimes in Java, there's these two ideas that you kind of need to understand. One is these POJOs, plain old Java objects, which just, they don't do much. They're called plain old Java objects, AKA POJOs, because they kind of just sit there. They have a couple variables. There'll be a little logic in them sometimes, but not much, because they just represent some data. And then we have this other idea, which I like to call controller classes. And the controller classes are what will use those objects. So like, for instance, we'll start from the main method, where we'll create, inside our main method, we'll create objects of the vehicle class and other classes that we're going to create. So basically, we have this controller kind of action thread that's using all of these Java objects that we're creating. So right now, we're going to focus on classes and objects. So let's design a vehicle. I'm going to keep it really simple and say string make, string model. How about we go with int year, and let's go with string color. A couple of different notes while we're here. We haven't really talked about strings yet. Strings are not a primitive data type. They are an object data type, meaning their value can't just be stored in one very simple string of binary, like the number 16 can. And more about objects will come here. But strings are basically how we hold words, sentences, paragraphs. And another thing in the last video, I basically mentioned that we comment using /* and then */ to get out. That is true for block comments, but there's 3 types of comments in Java that I just thought I'd clear up. We've got the block comment, which I just showed you, /*, and then */ to end that block comment. That's for blocking out, or for when you want to just have a large section of text, that's a comment. We've also got JavaDoc comments. So there's a tool that comes with the JDK that is called JavaDoc that will generate basically HTML files that describe your Java classes, and they make them readily available. It's easy for you to put them online, or for Oracle or Java or any other company to put their Java docs online to tell us developers what those classes have, what methods they have, and we can talk about that a bit later. But that right here, we've got Java doc comments. You can tell because they're always green. And then we've got very simple inline comments. So in front of any line, you can put // which will make it a comment. So just wanted to clear that up before we move on. Right here, we've got a very, very simple class vehicle, and it's done. We could stop right here. All of these variables are public, or right now they're actually default, meaning we have not made them private. We'll talk about access modifiers a little bit when we get further into packages. But this is a class that just represents a vehicle. And so if I go over here to our OOP controller, I can now say vehicle, let's say, my car equals new vehicle. And we'll say my car dot because these are in separate packages, which we'll talk about really quickly. So I'm going to go ahead for simplicity's sake, I'm going to make all these variables public right now. In a real world application, I'd probably make most of my variables private, and we'll talk about that in a minute. So now over here, I can just say my car dot color equals blue, and my car dot make equals Nissan. My car dot model equals Xterra, and my car dot year equals 2010. Now I've got an object of type vehicle. This object is called my car. This is how I created the object by using the new keyword, and then the class type vehicle. And this class type vehicle we just defined right here. I can make other objects of this vehicle class. So let's say your car, and copy and pasting just for speed. And let's go, how about yours is a red, how about Tesla? Model 3, 2018. And so now we've got two different cars here, two different car objects. Not you car, your car. And if I put something that people do very, very commonly is we could put what's called, to get this little message, I just held down the control key and then hit enter to bring up this generate menu. You can also go to code and then generate. We'll pull it up. And I'm going to say, not getter and setter, but toString. And basically that will just return a string. This is a method that overrides, meaning it changes the behavior of the toString method in the object class. Object.java is the root class, the root parent class of all classes in Java. And in there is a method called toString. We're going to change its behavior, and we're going to have this method return a string that basically just describes this object. So right here, if I say my car, I'll print it out, sout my car dot toString, and then sout your car dot toString. When I run this, you'll see that we have two separate objects. Nissan Xterra 2010 blue, Tesla Model 3 2018 red. We have one class called vehicle, but we've made several objects of it. A couple other things about classes and objects. So we have this idea of what's called a constructor. So public vehicle would be this constructor. And a constructor looks a lot like a method, which is basically the next thing we're talking about. But a method would have a return type here, like meaning void, it doesn't return anything, or int, it returns an int. A constructor has no return type, and it has the same exact class, same exact name as the class. And a constructor is what's called or invoked when the new keyword is used. So when I said vehicle, my car equals new vehicle, that since the new keyword was used, this constructor is called. And Java if you do not provide a constructor, Java will provide one for you, and it'll look just like this. But it doesn't actually, it stays in the behind the scenes, but like if you just don't do a constructor, it's fine. If you don't need one, it's fine. And Java will basically provide a constructor for you behind the scenes that looks just like this. But let's say you do want to do something, or you want to give people options. So oftentimes what people do are, let's say that this constructor will take in a string make. These are called arguments, constructor or parameters, arguments, parameters. So these will be called constructor parameters. So this constructor is going to take in a string make, a string model, an int year, and a string color. And then it's going to say this dot make equal make. This dot make basically refers to the instance variable of this class. These are the instance variables. They're the variables that describe the class. They're not inside any method. We're not using them as counters or indexes. They're instance variables. So they describe this what will be an object of this class. Notice that none of them are static, that none of this is static, because this is all going to be related to objects. Static is not related to objects. So this dot make basically means that this variable make up here gets the value of this parameter, also called make, that's coming in. It's a little confusing, but it's better than like having to call this parameter something that it's not, because this parameter is the make, right? And so I'm going to say this dot model equal model. I'll say this dot year equal year, and then this dot color equal color. So what I've done now is when somebody tries to create this class, see, I've got an error over here now because I'm not passing this vehicle class now has a constructor. And this constructor takes 4 arguments or 4 parameters: string make, string model, int year, and string color. I'm not passing any of those arguments. So if I want this to still work the way it is, I have to provide a default constructor that it can still use, which is fine. It's called overloading constructors. So I could just create an empty constructor, just like that, nothing else, and now my errors go away. So now I've got flexibility. So I can create a car in 2 different ways now. I could say, I can pass these arguments. It's called passing arguments or parameters. Was year last? I think year was. So now I can create this class, I can construct this class in 2 different ways. And see, notice how I have no errors here. And when I run this, it'll run just fine. Everything will print out just fine. Basically, because I'm just demonstrating here using 2 different constructors. This is the constructor that I made that takes 4 arguments. String, I guess it was make model color, wasn't it though, huh? Nissan Xterra blue. So make sure you get those in order, in the right order. So yeah, make model year color. Make model year color. Right. So I'm able to create this my car in 1 line because I've used this, what's called a fully qualified constructor. Or I can use the empty or default constructor, which takes no arguments, and I just have to set those variables later. But then I've got these objects called my car and your car. Let me just make sure I'm sticking on track here. Starting to understand classes, objects. Let's talk a little bit more about methods. So let's say that I want to be able to paint my car. It happens, right? So what I can do is I can create underneath the constructors, usually in the general order is instance variables, constructors, and then kind of other methods. I'm going to make a method called public void paint car. And it's going to take in as an argument a color. And then I'm just going to say this dot color equals color. And basically what this is going to allow me to do is paint my car. So if I say sout, or actually I want to paint it first. So my car dot paint, I could probably just call the method paint. And I'm going to pass it. What color should we go? How about green? And then if I print out my car dot toString again, it'll print out, you'll see that the color will have changed on my car. Nissan Xterra 2010 blue, Nissan Xterra 2010 green. So this is just an example of a method, right? I've got this on the vehicle class. I've got a method, and a method has always this kind of same format, right? So we've got the accessor, or basically why am I blanking right now? But the accessibility, public, private, default. It's got the whether or not it's static or non-static. In this case, it's we're non-static. We'll come back to what static is, because this deals with individual objects, such as my car. The return type is void. The name of this method is paint, and then this paint method takes in one parameter, which is called color, and it's of type string. And then you could do whatever, like in here we could say sout, you're painting your car plus color. So now if I was to run this again, you're going to see that when that method paint gets called, it prints out you're painting your car green. And then it comes back over to here and it prints out the line below. So something to think about here again is flow control and following where the code goes, right? So code inside a method goes from top to bottom. But here when we say mycar.paint, it actually jumps over to this other class and executes the code that's inside this paint method before coming back over here and executing the rest of the code in this main method. So other good, like just for example purposes, let's do, I'm just going to create another Java class. Let's call it math. And I'm going to actually, because there is already a math class in Java, I'm going to call this custom math. And inside this custom math class, we're going to have a couple of methods like public int multiply. And it's going to take in two arguments, int A and B. I go back and forth between, I actually call them arguments, but a lot of people call these parameters. So I just kind of saying both. And here, all I would do is basically say int C equals A times B, and then return C. Because this method, it's public, and it returns an int. That's what the data type, this method returns data of type int. It's called multiply. So I say int C equals A times B, and then I say return C. I could also, to make this quicker, I could just say return A times B. That totally works. So let's do one more. Let's do divide. So this will be A over B. Any of you programmers out there right now might be cringing because you know that this is an exception waiting to happen, but we'll come back to what that exception is shortly when we talk about exception handling. So now let's go back over to the OOP controller, and I'm just going to call this method demonstrate custom math methods. And this method does not yet exist, so I'm going to put my cursor in it, hit Alt Enter, and I'm going to create that method. It's a little shortcut. And the first thing I'm going to do is I'm going to say, so let's continue with what we were just doing and creating an object. But I'm going to show you why for the case like this kind of stuff, we actually don't want to create objects. We want this to be static, but they're not static yet. So let's create a new object of custom math called myMath equals new. Make sure that we're creating a new object. And then we could say like int sum equals myMath dot, I should probably say int result equals myMath dot multiply, let's say 56 and 876. Sout result. So I'm going to run this again. All this previous stuff is going to run. And then I'm going to call this demonstrate custom math methods method, which will execute this code. And we can see that it printed out 49,056. So let's jump into here real quick. We created this object called myMath. And then we say int result equals myMath.multiply. So dot multiply, remember, is the name of this method inside a class called custom math. What we did is we created an object of custom math called myMath. And then using that object, we can now call non-static methods from inside that custom math class. And remember, this multiply method takes an int A and an int B, and it returns an int. So remember, it returns an int. It takes in two ints and it returns an int. So that's why I say int result equals whatever myMath.multiply returns. And then I print out result. In this case, it returns 49,056. But, so we're kind of jumping around here, but this is a case where we actually want these methods to be static. And let me just show you why. Because these methods multiply and divide, they're not going to change on a case-by-case basis like these variables, et cetera, are in the vehicle class, right? In the vehicle class, I'm going to have my car, your car, her car, his car, all these other people's cars. And basically, it's like a blueprint for objects. And non-static variables and methods are the ones that interact with objects, meaning like the color blue on my car or the color red on your car. not with some method kind of like multiply. This is never going to change on an object by object basis, right? This is always going to be just, it is what it is. It doesn't matter if this is a blue car or a red car or whatever. It's just a multiply method, right? So we actually, and Java basically says we don't have to use an object to interact with those methods. We can just use the class. So now, because that multiply method is static, I can say custom math, which is just the name of the class, remember, and then the name of the method that's in it. So I can just say int result equals custom math.multiply 56, 876. And this makes more sense. I shouldn't need to use an object of a class in order to call a method on such as multiply. I would want to use an object, like for instance, if we go back up to mycar.paint, this is a non-static method, paint, because I want it to change a variable inside an object, my car, right? But in something like multiply or divide, and there's many, many others, there's no object involved. Like it's not my car, it's not green, it's not blue, it's not your car. It's just the multiply method. And so basically what we do to make methods available with outside the realm of objects is we say that they're static. While we're talking about static and non-static, let's talk about, so that's static methods. Let's talk about static variables. So I can also make a static variable. So let's say public static int num cars created. So what I'm going to do now is anytime a car is created, whether it be in the default constructor, I'm going to increment this number num cars created. And then no matter what, if I print out, and so right here, I'm going to say sout my car dot num cars created, and I'll sout your car dot num cars created. And we're starting to get a lot of things printing out here, but you can see that it printed out twice. That's because my car dot num cars created and your car dot num cars created are the same variable. A static variable is a variable that's shared between all instances, or instances is another word for objects. A static variable is a variable that's shared between all objects of a class. So watch what happens if I create another class. Where was that? Let's create a class called that car. And let's make this a Toyota 4Runner. $Renner 4Runner. And let's make this one gray. And that's it. I just made one more car. I'm doing nothing else. When I run this now, it'll print out 3 and 3 because there's been 3 cars created, and that static variable is shared between all cars. So like I don't know if this will make any sense, but you know, like if you're looking at artwork or photography, and in the bottom right corner, you'll see that this is like print 5 of 10, or print 3 of 7. That number 7 would be a static variable. Like the total number that created every painting or photograph shares that number 7 in that there was only 7 created. And then the 3 or the 5 is an instance variable, meaning that's specific to this one object. This one print is print 3 of 7. So I don't know if that helps. For some reason, that kind of helps me. So that's static and non-static. I've got about 5 more minutes here. Let's jump into object-oriented programming. So we've talked about objects and classes. We've got this class vehicle, which is basically just a plain old Java object. It describes a Java object. And then we can create objects of that over and over and over again. My car, that car, your car. And we showed how to create them using constructors in multiple ways. And remember this constructor too, we could make 5 constructors that are all different. That one takes just the make, one takes just the model, one takes just the color, or any combination therein. What I usually do is have a default constructor and a fully qualified constructor so that I have these 2 options, right? And there's no right or wrong there. It's just you do what you need to do based on the code that you're working with and the requirements. So object-oriented programming has 3 primary tenets. We've got encapsulation, we've got inheritance, and we've got polymorphism. So polymorphism, sorry, I'll start at the top. Encapsulation basically is somewhat simple. It just means that everything that makes up a vehicle is encapsulated within the vehicle class. For instance, I could make a class called cat, and everything related to the cat, its fur, color, its name, its whether or not it has a bell, is going to be inside the cat class. And then we have access modifiers, which is the word I couldn't remember earlier. Public, private, protected, and there's default if you don't put any access modifier. Again, like public, these are called access modifiers, kind of says who can see them and who can interact with them. And we'll come back a little bit to that. Encapsulation says that everything related to a vehicle will be found inside the vehicle class, and all the data that's related to a vehicle will be in the vehicle class, and all the methods that act on that data or modify that data will also be inside the vehicle class. It just encapsulates all the logic, data and logic related to a vehicle in one class called vehicle. That's encapsulation. It's relatively straightforward. Inheritance is basically, it's intuitive as well, but it basically says one class can inherit the traits, the public traits, public or protected traits of a parent class. For instance, unlike humans or animals, a class cannot inherit from two classes. It can only inherit from one class. But the reason I made this vehicle class was actually to demonstrate that, because there's all kinds of vehicles out there, right? Like, let's say that we're dealing with a sedan and a sports car and a motorcycle, right? They all share make, model, year, color, and a bunch of other things. A very common example you'll see out there is food, right? So take an apple and an orange. They're different, right? And if I was trying to write a class that basically described what an apple was and described what an orange was, there's hundreds of thousands of things, the attributes that both of those things have, right? To properly explain what an orange is. But between an apple and an orange, 95% of those things or more are shared, right? They're both fruit, they both have seeds, they're both delicious, they're both healthy, they've got great, they've got caloric value, they both grow on trees, they share all of these attributes. And when we see that happening, rather than write all of those attributes in the apple class and also write all those attributes in the orange class and every other food class that you might possibly need to write or to create, we just create one class called fruit. And things like grows on tree, has seeds, is delicious, is healthy, all those things are in there, right? And then our apple or our orange can just extend or inherit from that class fruit. And fruit, for instance, might inherit or extend the class food. And food might extend the class consumable. But basically, it makes it so that we don't have to write the same code over and over and over again. So for instance, right here, I've created a motorcycle and a sedan, right? So in our vehicle class, I'm going to create a couple more methods. So let's go with, and you can paint a motorcycle, you can paint a sedan, but let's go, every vehicle out there starts and stops. So let's say public void start. And then I'm just going to say south, the vehicle is starting. And I'll make another method called stop, right? All vehicles stop and start. So now this motorcycle, for instance, let me just go ahead and let's say int cc is what makes it different. So now all I have to define in motorcycle is what makes it different than a vehicle, right? So how about Boolean has double seat, right? That's not something that a normal vehicle that like just a motorcycle does. And let's just leave it there for simplicity. And then I'm going to create a constructor. And I'll do it just like I did before. I'll create a blank or default constructor as well as a fully qualified constructor. But check this out. When I say, I basically have direct access to, I need to say extend. So I'm going to say motorcycle extends vehicle. And as soon as I do that, now I've got direct, I need to import that. So to import, I say alt enter with my cursor in there, and that'll import that class into here. So because we're in a different package, since we're in a different package, I need to import it so that we can see it. Here, let's just say I'm going to say Kawasaki and model equal, I don't know, fast bike. And color equal, let's say black, and year equal 2016. So see how I'm using make, model, and color and year here? But those are not variables that exist inside the motorcycle class. Those are variables that exist inside the vehicle class, right? But the vehicle class now is a parent to the motorcycle class, right? that's just to demonstrate kind of what I would probably do here is if I wanted to set the super variable, they're called super variables. These are variables that are in this super class. This right now, the motorcycle is called a subclass or child class. Is I would take these in as arguments right here as well, rather than just hard coding Kawasaki fast bike, etc. But let's just go ahead and do that. And then I could do the same thing in sedan. So like sedan, maybe, you know, a tractor is a vehicle, a space shuttle is a vehicle, a scooter is a vehicle in some ways. So I'm going to say Boolean has sunroof and int num doors. You know, sedan could be 2-door or 4-door, and we'll just leave it at that. And I'm going to say extends vehicle. So now this class, sedan and motorcycle, both have direct unfettered access to all the public and private, import that again, members of the vehicle class. And a member means either a variable or a method. So for instance, in this motorcycle class, I can say, let's go over to our object OP controller. I'm just going to kind of comment all this out for right now. I'll come back before I'm going to show you guys, share all the source code with you guys. I'll come back and clean it up and push it up to GitHub. But so now let's create I'm going to create a motorcycle. Bike equals new motorcycle. And here I could say sout bike dot color. And remember in the constructor, or did I give it a color? That's right, because this is using, when I'm basically using the default constructors. So let's go ahead and just set these in both and run it again. So here in my OOP controller, you'll see that when I say system.out.println bike.color, it prints out black, because in the bike class, in the constructor, we set the color to black in both constructors. Right now we're using this default constructor because we're not passing any arguments. And then I can say, for instance, bike.paint. I'm going to paint it yellow. And then I can sout bike.color. Black, you're painting your car. Ooh, looks like I found a little bug. That shouldn't say car. I should probably change that to vehicle. And then it goes back, and then we see that the bike is yellow. So basically what I'm trying to demonstrate here is inheritance. The motorcycle inherits from the vehicle class, such as the paint method, the color variable, but it also has its own. I could say, for instance, plus, you know, has rear seat. Plus bike dot. Did I put a rear seat on the bike? Oh, I need a getter instead of. So because these are in a different package, again, we either need to make these public instead of default, or put give them getters and setters, which I'll go ahead and do, which just because they're very common. So I'm going to hit Control Enter to getter and setter. And now I've got a public get CC and is has double seat. So over here I can say bike is has double seat. And the reason I'm doing that is just to show that the bike also has the variables that make it unique, such as has rear seat, false. Polymorphism is the last thing we're going to talk about here real quick. And the reason I used a vehicle and a motorcycle and a sedan is that it's a good opportunity to show how a vehicle and a sedan probably start, you know, the same way, whether it be a tractor or a boat or a car. You basically sit down and you turn a key to the right, right? And maybe put a little gas with your right foot. Maybe not with a boat, but you know, a car, tractor, the vast majority of vehicles, trucks, sedans, SUVs. But a motorcycle is different, right? A motorcycle is going to start by turning the key or pushing a button, and then giving a little gas by using the throttle. And you might need to be holding in the clutch with your left hand. So what we can do there is that we can override the way that the start method works. Public void start. So this is the same method that we have in the vehicle class, public void start. But I'm going to override it in the motorcycle class, because in the motorcycle class, and for right now, I'm just going to say Sout motorcycle starting. You know, in the motorcycle class, the actions I need to take when I start it, even though it is a vehicle, a subclass of vehicle, are different. So I can override that. And that's an example of polymorphism. So let me show you that in action. So I can, let's create a, I'll just kind of get rid of this for a sec. I'll create a sedan, Honda equals new sedan. And then I'll say Honda dot start. And then I'll say bike dot start, right? I've got dot start on both of these methods because sedan and motorcycle both extend the vehicle, and the start method is in the vehicle class. So it looks like Honda's calling the same method as bike is, but bike is actually overridden that method and changes its behavior. And you'll see that because here it says the vehicle is starting and the motorcycle is starting, which demonstrates that this start method was called when I called it on the bike in the vehicle class, when I called it with the sedan, the start method in the vehicle class was called. And when I called it with the bike, the start method in the motorcycle class was called. So a lot of information there, but encapsulation, meaning everything about the vehicle is inside the vehicle class. Inheritance, meaning, you know, class motorcycle can inherit from class vehicle. And polymorphism, meaning that motorcycle can change the behavior of methods in the vehicle class and override them or change them. And the last thing about polymorphism is called overloading. We've already done it with constructors, where we have you know, multiple. This is a public vehicle constructor. This is public vehicle constructor. They have the same. It's two constructors, but they're overloaded. You can do the same thing with methods. So, and we've already been doing it a lot. And I'll give you a very, very simple example here. I'll comment all this out for simplicity, which is system.out.println. We've been using it the whole time. You can print out 10. You could print out, you know, hello. You could print out 1.234. These all work, right? Even though they shouldn't, because Java is a strictly typed language. So this println method either takes an int, or it takes a string, or it takes a double, right? It can't just kind of take all of them. It literally can't, because Java is a strictly typed language. We don't, for instance, when we say vehicle.paint, we have to say that the variable it takes in is of type string color. We can't just pass a number 12 to this paint method because it only takes strings. So we've already been using overloading and polymorphism by using the println method. And basically it's because this println method is heavily overloaded. So here's println that takes a char, here's println that takes a boolean, here's println that takes nothing, println that takes a long, println that takes a float, println that takes a double, char array, so on and so forth, string. And that's called overloading. The method signature is exactly the same, but the parameters or arguments that they take are different. So it makes it look like it's a single method that we're calling, println, but it can act in many different ways, many forms, polymorphism of many forms. So that's classes, objects, a bit of methods, and object-oriented programming in almost 30 minutes. Hope you enjoyed, and hope you'll join us for section 3, where we talk about, let's see here, exception handling, input, output, multi-threading, generics, enumerations, and lambda expressions. That one's going to be a good one. And then after that, in section 4, we're going to build out a cool blackjack game where we can play the computer in rounds of blackjack that includes betting and all kinds of fun stuff. So hope you've enjoyed, and looking forward to section 3.